Picture this, a single laser beam from the vast emptiness of space, packing the punch of a tiny light bulb, utterly dominating the high-tech web of satellites that powers our modern internet. It's not science fiction. It's China's latest breakthrough, and it's set to challenge everything we know about global connectivity. But here's where it gets truly mind-blowing. This isn't just about speed. It's about reimagining how we beam data across the cosmos. Dive in, and let's unpack why this could be a game-changer for everyone from casual web surfers to space explorers. In an ambitious experiment high above our planet, Chinese engineers have pulled off something extraordinary, sending data at an incredible 1 gigabit per second, often abbreviated as Gbps, from a geostationary orbit using nothing more than a 2-watt laser. For context, that's the kind of power you'd find in a standard LED bulb in your home. This signal, originating from a dizzying 36,000 kilometers up, far beyond the reach of most satellites, surpasses the capabilities of Starlink by a whopping factor of 5. And get this, it achieves this feat without gobbling up enormous amounts of energy or needing a sprawling fleet of thousands of satellites. Imagine streaming high-definition movies or conducting video calls with zero lag, all powered by something as simple as a focused beam of light. This groundbreaking work, spearheaded by experts at Peking University and the Chinese Academy of Sciences, harnesses an innovative optical setup that keeps data intact even when faced with the challenges of immense distances and the swirling distortions from Earth's atmosphere, like the atmospheric turbulence you might see in wavy heat mirages on a hot day. For beginners, think of it as a super smart system that corrects blurry signals in real time, much like how your phone's camera adjusts for shaky hands. With this proof of concept, China is offering a fresh take on satellite internet, steering away from the low Earth orbit (LEO) systems that are currently the norm in the industry. The test took place at the Lijiang Observatory in southwestern China, marking a real-world step toward laser-powered networks. These promise not only blistering speeds, but also lower delays in communication and wider channels for data flow compared to the radio frequency (RF) methods we've relied on for so long. And this is the part most people miss. It's not just about tech demos, it's paving the way for a future where space-based connections are as reliable as your home Wi-Fi. Shifting gears, escaping the LEO crowd. China's approach flips the script on the packed LEO strategy favored by giants like SpaceX, which deploys hordes of satellites buzzing at just 550 kilometers above Earth, close enough that they orbit quickly but require constant replacements and massive numbers for worldwide coverage. Instead, the Chinese team showcased a speedy optical connection from a geostationary satellite, GEO, which hovers stationary at over 36,700 kilometers, always in the same spot relative to the ground. This stability is like having a fixed tower instead of a swarm of fast-moving drones. As detailed in reports from the South China Morning Post, the trial hit that 1 gigabit per second mark with a mere 2-watt laser, keeping the signal crystal clear over a distance that's rarely tackled for such heavy data loads. The magic happens through a clever combo called AOMDR synergy, adaptive optics, AO, tweak distortions on the fly, like auto-focusing glasses for the laser beam, while mode diversity reception, MDR, picks up scattered parts of the signal that might otherwise be lost. Then a multiplane light converter, MPLC, divides it into 8 channels, and a smart algorithm picks the best paths, slashing errors. This isn't just jargon, it's what makes long-distance laser comms possible, turning potential failures into flawless transmissions. For a deeper dive, check out Interesting Engineering's breakdown, which notes how this boosted the effective signal strength from 72% to 91.1%, a leap that ensures rock-solid stability over extreme ranges. As an example, imagine trying to send a video call across the ocean with 100% clarity. This tech makes that a reality without the fuzz. Lasers versus radio waves, the battle for bandwidth. While Starlink keeps expanding its LEO empire, delivering average download speeds around 67 megabits per second to users on the ground, China's laser test hints at a smarter way to scale. Old-school satellite systems using radio waves are hitting walls due to crowded airwaves and strict rules from regulators, Think of it as rush hour on a highway where everyone wants the fast lane. Laser systems, on the flip side, provide way more room for data, dodge interference like a pro, and focus beams so tightly they can target specific spots without wasting energy. But here's where it gets controversial. Critics might argue that lasers could be too precise, raising privacy concerns if governments use them for surveillance. Is this a step toward freer, faster internet for all, or a tool for more targeted control? And this is the part most people miss. Lasers cut down on the need for massive power boosters. The Chinese setup used just 2 watts, equivalent to that LED bulb, to blast data from over 36,000 kilometers, versus the hundreds of watts RF systems burn for similar reach. It's like switching from a gas-guzzling car to an electric scooter for efficiency. The study, published in Acta Optica Sinica, reveals they employed 357 tiny micromirrors in the adaptive optics setup to reshape atmospheric distorted signals. The end result? A robust signal ready for instant processing, shrugging off environmental noise. For beginners, this is akin to polishing a foggy window. Suddenly, everything comes into sharp focus. Building blocks for space security and cosmic adventures. This demo's ripple effects go well beyond everyday internet. Robust laser links from geo-orbits could revolutionize military ops, secure government chats, and even relay data from deep space missions. Lasers are harder to detect than radio signals, making them perfect for encrypted messages. Think invisible ink in the digital age. Though presented as pure science, China's push into space tech whispers of bigger strategic plays, potentially reshaping global power dynamics. And this is the part most people miss. Lasers enable quicker control of missions to the Moon or Mars, aiding projects like turning lunar dust into bricks for habitats. Their low delays and error rates are gold for critical data, where RF struggles with interference or vast distances. But here's where controversy brews. Could this tech be weaponized, like blinding enemy satellites? Or is it a peaceful leap forward? The debate is on. The big hurdle ahead? Scaling it up. China must launch more geo-satellites with pinpoint optical gear and build a network of ground receivers worldwide. Yet, the bang for buck of laser geo could eclipse LEO swarms, which need armies of satellites for full coverage. It's an efficiency revolution waiting to happen. What do you think? Will China's laser leap democratize space communications or ignite new geopolitical tensions? Do you see lasers as the future of internet, or does the shift away from LEO constellations worry you? Sound off in the comments. Let's discuss.